Live streaming on YouTube from Rockwell Automation Fair. My name is Matt Kirkner, your host for this and every episode of the Tech Guide Podcast. What an incredible day we're having. There is so much excitement around the world of Industry 4.0, advanced manufacturing, Industry Infinity 0.0, whatever we want to call it. Lots of discussions around connected systems, digitization. Here at Rockwell Automation Fair, this entire event is all about optimizing productivity, empowering workers, managing risk, driving sustainability, and accelerating digital transformation. Those are just some of the keywords that we are hearing about as we talk with some of the most interesting people in the world of advanced manufacturing, education, and technology. Our next two guests fit perfectly into that category. The first one I'll introduce is Tim Beatty. Tim is the Director of Business Development for Arizona State University, Ira Fulton School of Engineering. Tim, it's so good to have you with us.
Thanks for having us.
And next to Tim, we have Jerry Gintz. And Jerry is a senior lecturer with the ASU Fulton School of Engineering Polytechnic Campus. And Jerry, it's great to have you on as well. So we are going to dive in first with a question for Tim. Now, you've got a really, really successful School of Engineering. I was blown away, Tim, as I learned a little bit about just your size, your scope, your enrollment. I understand you're actually the largest engineering school in the United States. So tell us about that. How many enrolled students do you have, and what do you attribute all the success you're having in recruiting students and producing amazing engineering talent to?
Right. Thanks for having us. The ASU Engineering School story is really one that started many years ago when Dr. Crow joined and led our university. We reorganized our engineering school, but currently we are over 30,000 in total enrollment,
wow,
both undergrad and grad.
That's incredible.
And we're composed of 7 different schools. And the last, newest one that we just launched is the School of Manufacturing Systems and Networks.
Wow, so 30,000 students, that kind of blows the mind. I mean, that's just, and obviously you're doing some great things that are attracting all these students to the 7 different schools of engineering. Is that what you said? Did I hear you
Yep.
correctly? So what is it that attracts a student to ASU from an engineering standpoint?
I think it's the opportunity and accessibility. We're a state university that believes in access, and our charter as a university is about who we include, not who we exclude. And so we know that we need to have an impact in the communities that we operate in, and we know that there's an acute engineering shortage of talent in the country, and ASU is just trying to do our part in continuing to grow our school.
And go ahead, I'm sorry.
The goal that we have right now, which is aspirational, is to grow to over 40,000.
Wow.
We just graduated 5,000 students this last academic year, and our goal is to get over 10,000.
That's amazing. Think about 5,000 skilled engineers going into the workforce, driving change as we walk around here at Automation Fair and seeing this incredible technology. It is just the most amazing time in history, I think,
yes,
to be an engineer, to be entering the industry with all the great things that they're learning at ASU. So really, really exciting time. One of the things that you just said I think was just perfect, and that is this whole idea of your charter being not who you exclude, but who you include. And I think so often when we think about higher education, it's like, are you good enough? Do you have a high enough SAT score, ACT score? What was your grade point? What was your involvement in, whatever? Are you the kind of person that can make it in the world of engineering? Are you smart enough to be one of us? And really, you've kind of turned the tables on that whole thesis and said, look, engineering is for anybody and everybody. And as long as you can in one way or one shape or another, hack the academic rigor and find your way through, and you're willing to work hard and you're willing to learn it at a reasonable pace, there is a place for you, and we are going to turn you into a skilled engineer. And I think a lot of times from an engineering standpoint, even in industry, you get a little bit of the, and I don't want to call it elitism, but I guess I will. Like, back, up in the ivory tower of the engineering department, and you've really, I'm going to use the term democratize this whole approach to engineering and said, let's cast as broad a tent as we possibly can. 30,000 is a great goal, but 40,000 students is an even better goal, so that we can provide the kind of engineering talent that we're going to need in the future. Jerry, I want to talk a little bit about that talent and some of the things that ASU is doing to create that next level of talent. Now, Just last month, 200 affiliates, or ASU affiliates rather, and over 200 industry members, and including the likes of some really recognizable names. I see Fanuc, Honeywell, Sesame, celebrated the launch of your new School of Manufacturing Systems and Networks. I can tell you, if there's a theme that we've heard on the Tech Ed podcast today about what's going on here at Rockwell Automation Fair, it really is this whole idea of systems and networks, of global enterprise, of understanding digitization, understanding how things like Industry 4.0, abilities to crunch information, to gather data, to network all of our systems together. I mean, that is a theme of this event. That's been a theme of the podcast all day. So tell us, what is the School of Manufacturing Systems and Networks?
Well, the School of Manufacturing Systems and Networks is core to being able to digitize or see the digitization transformation of manufacturing. The idea here is to bring our students through a comprehensive review of manufacturing, starting with processes, meaning subtractive, additive, and formative.
Sure.
And then using those as a foundation for further research and further study. The goal of where we're at with the advanced manufacturing, or the transition we're moving to, is this idea of, or what's out there now with the lights out manufacturing,
right,
and how we work as a community to achieve that goal. So what we need to do is work with our students, have them follow their passions, figure out exactly where they fit in that transformation, and then utilize those talents to realize this goal for bringing manufacturing home, or
Fantastic.
onshoring manufacturing.
Absolutely. You know, somebody used the analogy yesterday, and I'm dating myself a little bit with the Laverne and Shirley episode when they were working in the candy manufacturing facility, and thinking about people standing at a production line trying to keep up with the pace of a manufacturing operation. It was a hilarious episode. And I've worked in some manufacturing plants that looked a little bit like that over the years, a long time ago. That is not the world of this new age of manufacturing, to your point, Jerry. It really is. It's digitized. It's networked. It's lights out. For our listeners that maybe don't know exactly what we mean by lights out manufacturing, it is literally lights out manufacturing. You leave the plant floor at some time of the day, turn off the lights, and the equipment continues to run, continues to produce parts. And then we just gather data. So we're using things like predictive analytics. We're measuring things like force, disturbances, temperature, moisture on manufacturing operations, gathering all that data over time from millions and millions of sensors and devices, and then using that data to predict the future. And it really is becoming predictive. It's about how do we avoid a problem before it ever happens. And then to your point, all of this manufacturing technology anymore is completely connected. You walk into a really advanced manufacturing operation, CNC machines connected to the cloud, robots are connected to the cloud, robotic weld cells connected to the cloud, all gathering data, all feeding it up to a cloud level computing, crunching that data, and like we said, predicting the future. If something we don't like is going to happen, we take action to change it, and it's really driving incredible innovation in the world of manufacturing. I'm really, really excited to watch this School of Manufacturing Systems and Networks continue to grow and to see the great, amazing opportunities that are going to be available for your students. Now, Tim, I know that kind of innovation and that kind of a program cannot happen without just incredible industry partnerships and really working with your community, whether it's software companies, hardware companies, manufacturing companies, and so on, and building those relationships. So I'd be interested, Tim, in understanding how ASU goes about incorporating the guidance and the needs, for that matter, of your industry partners into the overall strategic decisions, the curriculum, and the experiences of your students in the engineering program.
Yeah, great question. We do it in multiple different ways. We have very active industrial advisory boards that help guide each of the 7 schools, and then the Dean of Engineering has his own advisory board as well, and that board is leveraged to really develop longer-term strategic planning kind of questions and challenges, and get a very well-rounded perspective from multiple different industries. And we'll be standing up our industrial advisory board for manufacturing school this spring, and obviously we're going to be involved with many of our partners that we work with. The other thing that is very apparent is that companies coming out of COVID, every conversation starts with workforce access and securing a pipeline of talent out of the engineering school. So what we try to do is explain to companies and work with them on how do we develop a strategy that's going to work for their business. And that can come in not just access to talent, but also engagement with students, engagement with faculty, bringing in guest lecturing on specific technologies into the classrooms so our students hear from industry experts, what's current, what are the new challenges that they're working on, and where our curriculum can actually move into that area to help produce talent that will address those needs. And we have fabulous engagements with lots of different industry across Fulton.
Sounds like a really, really good approach. A lot of times we'll get questions from industrial employers about how do we become more engaged with our, our higher educator, whether it's a technical or community school, a four-year engineering program, and so on. And one of the first things I say to them, and you hit on it right off the bat, which is, do those programs have an advisory board? Are you serving on the advisory board? Does the dean of the program know what it look like? What are the lessons that are going to be delivered? And here's the secret. We tell people, like, how do we get access to this talent coming out of these amazing schools? It's like, if you're standing at the end of the line or you're standing there on graduation day hoping to get a hold of one of these students, it's like, it's way too late. You've got to be engaged in the advisory board. You have to be engaged with the student. I love your idea also about listening specifically to these individual employers and saying, well, how can we help you? What is it that you're looking for? And then inviting them in as guest lecturers to share what's going on in the world of advanced manufacturing, in the world of technology, with your engineering students, which serves two purposes. Number one, it educates that student about what's happening in manufacturing. I will also tell you it educates that manufacturer about what's happening in education, and it's a really, really solid way to build a strong, strong partnership. One of the things that we hear, and I'll pose this question to both of you, starting with Tim since you've got the microphone, we hear this from industrial employers. They'll say, look, a lot of our schools are teaching physics, they're teaching calculus, they're all the gen eds, these students can do math backwards and forwards, understand it from one end to the other. But then when it gets into a manufacturing environment and they're integrating the kinds of technologies we're seeing here, advanced robotics, advanced automation, programmable logic controllers, variable frequency drives, conveyors, digital twins, putting all those pieces together, they say sometimes we almost have to start over and teach the students advanced manufacturing before they can add tremendous value for us in our operation. Do you hear that from some of your industrial employers, and how is ASU going about making sure that as you're producing engineering talent, these are students who understand how all these pieces fit together?
I would say that's a constant theme besides needing a secured pipeline of talent, is how to make sure that you incorporate applied, hands-on engineering curriculum into your curriculum so that students understand context and understand how that affects or what they're working on impacts the manufacturing processes. So some of the ways we do that is we have a curriculum out at the School of Manufacturing that's based on hands-on, team-based learning.
Okay.
And it starts freshman year all the way through graduate school. We have a lot of different industry engagement opportunities with the curriculum throughout their undergraduate experience. And one of the things that we really stress on is our senior capstone project are all industry designed and developed problem statements and mentored by industry so that students get access to a problem that's actually relevant to a current manufacturing or an engineering challenge. And that's one of our core elements of our curriculum as well.
So a student in a capstone project is working on a real world solution or project for an employer that's been devised by that employer, and then working hand in hand with representatives of that employer to solve the problem.
And it's, by the way, it's one of the best ways for that industry partner to gain access to talent,
right,
with a very low risk, very low investment for them to then provide a job offer.
Absolutely, yeah, exactly. Put who gets to actually put a potential employee on a project before you even bring them in the front door and see is their culture fit? Do they think the way we'd like them to fit in? Is their synergy? I really like that. And as we turn that same question to Jerry, I just want to reflect up for a moment on one of the things, Jerry, that Tim said. The word that he used was contextual, and having a context for what we're learning. And I really like that. It distills down to really one word what a hands-on polytechnic opportunity in education is all about. I was always a hands-on learner myself. And I think a lot of the people that find their way into manufacturing, find their way into engineering, you get to engineering because you're interested in building stuff and making stuff, and maybe you were hands-on in a first robotics program or in a Lego league when you were going through school. Maybe you're in an automotive program and you're working with your hands in automotive. But we have these experiences hands-on in high school, and then we get to college, and in a lot of cases, not every case, we're spending 2 or 3 years sitting at a desk getting lectured on on physics and calculus. Great, but getting hands-on learning is just so very important. So same question for you, Jerry. Are you hearing the same kind of things from your employer? And then are there examples that you can call up about how we're getting around this need for hands-on skills and hands-on experiences?
Well, to follow up where Tim left off with context, it's all about introducing the students to the context.
Okay.
Primarily because the campus includes an array of engineers, multidisciplined engineers.
Sure.
So for them to understand where they fit in the ecosystem and how they can align their personal interest with what the needs of industry are is absolutely paramount before we sit them down and try to teach them the specific engineering disciplines.
Sure.
So to that side, most of what we do as a polytechnic is whatever theory we're trying to teach, we follow that up immediately with a hands-on laboratory exercise, somewhere where they can actually engage themselves in the full solution. And we split our teams in a multidiscipline format. So we represent different viewpoints on each team, which seems to really bring them together to a solution. Having the industry involved in that, bringing a real world problem, not something that we've made up or is academic, but something that actually will solve a problem, is central to what we do. Our students are all about make a difference. They're all about how does what I do matter? And to that end, we need to bring that out in them. Once we do that, they are fully engaged in the next step. So the pipeline that we typically use starts at high school, community college, and then comes into us. So what we do is we just simply add to what the others have provided as foundational. To that end, we would teach systems level. So now we're going to bring those concepts together of the different components, and then they will come out with a systems solution. And that multidisciplinary team system solution resonates with this group.
Where was this approach to education when I was going through my education pathway? I love what I'm hearing. So it's a little bit of theory, followed immediately by a hands-on application and understanding of how that theory is going to manifest itself in a physical system, and then taking on top of that all of these different pieces of, how do I integrate all these individual components into a system? And your approach is hitting on all three of those. Am I understanding that right?
You are, and the most important part is application.
Right.
Teaching math for the sake of math doesn't bring an engineer to light.
Right.
But as soon as you take that same situation and put it to application, now all of a sudden they see the light and they're immediately engaged. So that's what we try to do. So that's what I meant by the theory followed by hands-on. It's really an applied theory approach. Every single semester we have a project-related course.
Wow. It sounds like you're so far ahead of some of the trends that we're now finally seeing in education, with people understanding the importance of hands-on learning, the importance of hands-on context. And we're starting to see that sea change, I think, in education. We're also seeing it at the public policy level. And Tim, one of the things that I wanted to chat about with you, and this is hearkening back to a guest that we had on the Tech Ed podcast about 2 weeks ago. I think we released his episode, and that was Senator Todd Young, who's the senator from the state of Indiana. He co-sponsored the CHIPS and Science Act alongside Chuck Schumer through the United States Senate, and that act, of course, later became law when Joe Biden signed it into law on August 22nd of this year. Does that act impact the research that you would be conducting at the School of Manufacturing Systems and Networks? So we've talked a lot about these contextual opportunities for engineering students. Now we're talking a little bit more about research. So either at the School of Manufacturing Systems and Networks or at the Fulton School of Engineering, in general, what are some of the emerging technologies that you're starting to think about as legislation like the CHIPS and Science Act starts to fund some really, really cool endeavors in the world of higher education?
So ASU's been very, very involved with the CHIPS Act, the writing of the bill, and also we're now obviously pursuing the grant funding that comes with that. If you've been tracking anything that's going on in the Arizona economy the last 5 years, you know that the semiconductor and power electronics economy is booming in Arizona,
right.
along
and will
with
continue to, it sounds like,
electric vehicle and battery technologies and such. We are very active as a School of Engineering, and also how we're designing the new manufacturing school to take advantage of that and meet the need.
Sure.
So there's a lot of work being done in reimagining what the new semiconductor manufacturing processes might look like, more sustainable, more digital, more leveraging different kinds of technology and VR, AR as an example. And so both the academic focus and the research focus is in those areas. The university also has stood up through the funding from the state of Arizona, through the New Economy Initiative, science and technology centers, and one of them, well, there's two of them that are focused on advanced manufacturing, as well as semiconductor and power electronics and battery technology. And those are research projects and funding that are co-developed with industry partners. So the ecosystem of research that's being developed at ASU has very applied solutions that we're focused on in the semiconductor and microelectronics, which supports the CHIPS Act and
right.
All those different opportunities.
Fantastic. It sounds like it's a perfect example of what can happen when we get as aligned as possible between industrial employers, public policy makers, educators, and for that matter, understanding geopolitical trends that are taking place and how they're going to shape our future. Obviously, Arizona way on the front end of that, investing in things, as you suggest, like power electronics, like semiconductors, and like technologies. It's going to be just fascinating to watch how this all rolls out as time goes on.
Yes.
Tremendous funding now coming into the world of research, especially as it relates to some of these technologies. I think that Americans started to realize over the course of the supply chain challenges we've had are so fundamental to the way of life here in the U.S. And we like to say when you can get what you want, when you want it, at a price you're willing to pay for it, it's really easy to take advanced manufacturing for granted, right? The stuff I go to Amazon, I say what I want, it shows up on my doorstep. What's so complicated about this? And now here we are in an environment where the world hasn't exactly worked that way over the course of the last couple of years. To Senator Young's point, when he was on the podcast, in some ways if we haven't fallen behind, we've certainly lost our edge in some of these technologies, and it's time to reinvest, make sure that we can control for all kinds of reasons, our way of life, our national security, and so on, the supply chain here at home. I like to tell people, if there's one silver lining to the pandemic and the supply chain challenge, it's that the rest of the world now knows what those of us have been around advanced manufacturing knew all along, which is without advanced manufacturing, there is no United States of America as we know it. So credit to you for making those investments in these really cool emerging technologies. And as we close out our time with a few more questions, amazing how quickly an hour, a half hour rather, can pass by. We're here at Rockwell Automation Fair. Thousands and thousands of like-minded people learning about all these really amazing technologies. It's been an absolute pleasure to see what's going on here. As you've made your way around the show, anything in particular, I'll ask you both, starting with Tim, anything in particular that jumps out to you that was like, wow, that was a really, really cool thing to see?
Well, I think the purpose for Jerry and I to be here is really to connect with our industry partners that we're really investing in industrial automation in our classrooms, like Fanuc and Rockwell,
yep,
which are great partners of ours. And we're trying to understand where's the industry moving so that we can develop the curriculum and have the facilities in the classroom that's going to meet those needs. We need to be thinking about 5 years from now, not what is the current need. We need to be thinking about 10 years from now. And with the investment in industrial automation that we have with Fanuc and Rockwell, that's going to help us provide a platform, and now we're looking at other technologies that we need to actually focus on in the classroom, and fabulous faculty like Jerry is going to be teaching that in the future.
How do you attract 30,000 students to your university? You think about what's going to happen in 5 to 10 years, and then you find awesome faculty like Jerry, who we're about to ask the same question to be able to deliver that incredible learning to students as technology continues to advance. So I'm sure, Jerry, you and Tim have been walking around making these great connections with your industrial partners and so on. Anything that jumps out at you that you've seen that's particularly cool?
Absolutely, Matt. One of the challenges we have is scaling up for those huge numbers. To do that, what we're looking to digital twin to be one of our assets where we can bring more students in. The one thing we didn't discuss yet is the multifaceted approach we're taking to education. Not only do we have a standard curriculum for engineering, we also support a DOL initiative for workforce advancement for both the incumbent workers and our students as we upskill them to align with what the industry's needs are. To that end, we need to be able to support these different populations that are coming in with different needs.
Sure.
And the easiest way we see, or the most effective way to do that, is through digital twin.
Yep.
We recreate what's there. We offer courses or content that can be consumed at a rate for the student. They progress at their speed. This is for the workforce now.
Yep.
And we're doing that through micro-credentialing, so that if we go back to MSN, what we have here is our students being able to go through a curriculum in engineering, but also participate in a parallel path that is in skills development and credentialing. So when they leave us, when they graduate with us, they walk out with their engineering degree, but also certifications, industry recognized certifications in those competencies that align with their interest. So now the employer has a much more enlightened look at how that particular candidate may fit into their ecosystem.
Absolutely. Great ways of accelerating education. You know, we talk about digital twins, emulate 3D here, of course, and seeing the amazing things that they're doing on that digital twin side. For those who don't know, that's Rockwell's investment in the world of digital twin, and doing just incredible things in creating experiences in the manufacturing facility to be able to design and innovate ahead of the physical implementation of a solution, but also on the education side, to your point, being able to use that digital twin so that students can experiment and succeed, and probably more importantly fail along the way, getting those hands-on skills and hands-on experiences that you also suggest, Jerry, on the path to micro-credentials, which is another emerging trend that it sounds like you're way ahead of. But you know, so for so long, especially those in higher education, would be, well, isn't our bachelor's degree, isn't our master's degree enough? Why do they need a micro-credential? It's like, well, inside of a degree program, you can have all kinds of electives, all kinds of competencies, all kinds of different things to emphasize, and through the use of micro-credentials, that's a really, really great way to establish to a potential employer as a student is graduating, yes, I've got this degree from an incredibly reputable institution, and I also have all these other things that I learned how to do while I was there, and here's the documentation that supports that. So just really impressed with how forward-thinking you are. It's obvious why folks like Rockwell and Fanuc would want to be closely partnered with you, because you really are true visionaries when it comes to higher education. Speaking of being a true visionary and kind of thinking about the future, we're actually going to turn the clock back a little bit to being sophomores in high school and think about what our future could have been or would have been and is now. And I'll start with you, Jerry. One piece of advice for a high school sophomore as they think about their future, what would it be?
If I had one piece of advice to share, it would be follow your passion. As you progress through your engineering degree or whatever degree path you're going to follow, make sure you align with what you want. What I tend to tell my students in a university format is, don't chase money, chase your passion. So many students get sidetracked by thinking they need to make a certain income,
right,
as opposed to just follow what you do best. The money will come later. And that's what we do with this micro-credentialing. We give them an opportunity to sample different areas and find where they fit.
I love it.
So that would be my advice.
Yep, follow your passion. I absolutely love that advice. And Tim, same question to you, high school sophomore, one piece of advice, what would it be?
Be curious and explore. There's at that age, you have your entire life in front of you, your career in front of you. It's a journey. I wished I would have explored a little bit more in terms of other fields, but I settled on an area that I actually was very passionate about in metallurgical engineering.
Wow.
And I went to school at Michigan Tech, which I never thought about doing that when I was very young, but
right. A little bit different temperature at Michigan Tech than in Arizona, right?
And this was a nice summer day today
right,
in Chicago at Michigan Tech. But anyway, just have that curiosity, explore, and talk to people that you really look up to that have a great career, and ask a lot of questions.
Absolutely. I love that idea of exploring. I love the idea of being passionate and following what it is that you're passionate about. Kind of tying those two things together, I was mentoring a young person who's in their junior year of college right now. And we're looking for an internship next summer, which, by the way, I'm telling you right now, when it was November of the year before June, I was not worried about what internship I was doing, but now, and that's like they're obsessing about it. And she was like, well, this company turned me down, and I'm not sure about, and all this pressure. And I'm like, my goodness, it's 2.5 months of a 45-year career.
Right.
Don't worry about it. It's going to figure itself out. But having that perspective when you're younger is difficult. And so I think it really makes sense. Look, it's none of these are life decisions necessarily. They might be, but you can always undo a decision. And if you're passionate and following your passion rather than the money, and you're exploring a lot of different options, the odds that you land on a really, really cool career opportunity is exactly where you'll be. I'm really glad that we landed on this interview and that we put the two of you on the Tech Ed podcast, just doing such amazing things at Arizona State University. Both Tom Beatty, the Director of Business Development, and Jerry Gintz, Senior Lecturer with the ASU Fulton School of Engineering. I want to thank you both for spending some time with us on the Tech Ed podcast.
Thank you, Matt. Great to have you.
Good.